In this video, we're going to go over function composition. So what is function composition? Function composition is when you evaluate one function based on the results of another. So we're going to go over right now function composition by going through and doing some things, okay? So let's let f of x be x plus 2. Let's let g of x be 3x plus 1, okay? And I'm going to ask you to evaluate each of these, okay? Number 1, evaluate f of 2. So what would you do if I said evaluate f of 2, okay? Well, you're going to let the input of f be 2 and see what you get as the output. So everywhere there's an x in f, you're going to replace it with this input value, right? And 2 plus 2 is 4. Number 2, if I said g of -5, what are you going to do? Well, you're going to replace every input in g with this, -5. 3 times -5 plus 1. Whoops. Times -5 plus 1. That's going to give me -15 plus 1. That's going to give me -14. Number 3, if I said g of smiley face, what are you going to do? You're going to replace the input in g with smiley face everywhere there's an input of g. So that's going to be 3 times smiley face plus 1. Number 4, if I said g of f of x, okay, what are you going to do? You're going to replace every x in g with the function f of x. So, okay, instead of it being smiley face now it's function f. Function f is x plus 2. So now we just have to simplify our new function that we're going to get. That's going to be 3x plus 6 plus 1. That's going to be 3x plus 7. This right here, number 4, this is function composition. Okay? The result of g came from, sorry about that, we evaluated g based on the results of f of x. Okay? So basically, the input of g is the output, okay, of putting numbers into f and getting what they would be, okay? So this is function composition. Basically, when you input one function into another. So now we're going to work on function composition. So before we get started, the first thing that we need to discuss is domain. When you're checking the domain of a newly composed function, which is also called a composite function when you're performing function composition, you need to check the inner function, which is g of x. That's where, if you think about that's where the x's actually funnel through first if you were to plug in x values. Okay, you have to check the domain of g of x, okay? And, whoops. And you also have to check the domain of your newly composed function f of g of x, okay? So you never really have f of x. You have values filtering through g of x, and then, okay, you have the values that are going through f of g of x. So here are 4 functions. We're going to work with these 4 functions, and we're going to find each composite function. So I'm going to show you the 2 ways you might see it. You might just see it like this, okay? But another way you can see it is actually, might look like this, okay? It looks like it says fog. That's an open, tiny little circle. That's also the, that means take the composite. And if you see it as f of g of x, okay, that's how you say it, f of g of x. These 2 are the same, so notice g is the inner one, okay? Now, what this is saying, f of g of x, means you're going to evaluate f, okay, at g. So you're going to stick, I like thinking of, what am I going to stick in what? I'm going to stick g of x in f of x. So everywhere, okay, everywhere in f, I'm going to stick in the function 2x minus 5. Wherever there's an input in f. I have 2 inputs, okay? I have an input squared plus 2 times an input minus 23. So that's going to be 2x minus 5 squared plus 2 times 2x minus 5 minus 23. Okay, now I just need to simplify this expression. So I have to expand this. This is going to be 2x minus 5 times 2x minus 5. This is going to be plus 4x minus 10 minus 23. Now I have to do 2x minus 5 times 2x minus 5. That's going to give me 4x squared minus 10x plus 25. And then I still have plus 4x minus 10 minus 23. So that's going to give me 4x squared, okay, negative 20x plus 4x, negative 16x, 25 minus 10 minus 23. That's going to put me at minus 8. So now, were there any, this is where you look for domain, were there any domain restrictions in the first place that x's would filter through, 2x minus 5? No. Now you never really have x squared plus 2x minus 3. Look what you end up having. You have this thing, right? You have the new function of g inside of f. So you look at the inner, g of x, okay? And then you just look at your newly composed function. Do you have any domain restrictions here? No, so your domain is all real numbers. Okay, so let's do another. In number 2, we'll do, okay, looks like it says golf. That is just the symbol, okay, that represents composition. It's smaller than like an O. It would be like that, okay? So what this means is we're going to do this, g of f of x. So what we're going to do here is we're going to stick f of x into g of x, okay? So x is, okay, if you were to put in a number here for x, if I said evaluate this composite function when x is 1, okay, it would first, the input value of 1 would first filter through f, okay? So everywhere in g that there is an input, we need to plug in x squared plus 2x minus 23. So that's going to be 2 times x squared plus 2x minus 23 minus 5. That's 2x squared plus 4x minus 46, okay? And then don't forget this minus 5. So it's going to be 2x squared plus 4x minus 51. And now for our domain. We check the inner. Was there a domain restriction? No. We check what we now have here. Was there a domain restriction? No. So the domain here is all real numbers. Okay, number 3. Number 3, let's do, okay, so think about this for a second. You might want to pause, think about what you think this might be to do. Try it on your own if you want, and play the video. So this says take G and stick it into N. So everywhere that there's an input in N, we're going to stick in for that input 2x minus 5. So this is going to become the square root of something plus 1. That's going to be 2x minus 5 plus 1. So there's nothing outside of the parentheses here, so this would just be the square root of 2x minus 5 plus 1. So that's going to simplify to be the square root of 2x minus 4, okay? So now we just check for our domain restriction. So was there a domain restriction for g of x? No. But now, do we have any domain restrictions here? Yes, because we cannot have a negative under the radical. So we have to make sure that 2x minus 4 is never negative. It can be anything but a negative number. So that means that it can be greater than or equal to 0. So 2x has to be greater than or equal to 4. Okay, we solve this inequality. X has to be greater than or equal to 2. So the domain here is x is greater than or equal to 2. Notice, we do not take into account the outer function's domain here because we never really have the square root of x plus 1. We have 2x minus 5 inside of the square root of x plus 1. That's why you only look at the inner function and your newly composed function, okay? We don't need to look at the outside one. All right, let's do one more. Oh, I named them both G. That's not helpful. Let's call that P. Sorry about that. So let's do P of F of X. So we're going to stick F into P. So everywhere that there's an input in P, we're going to stick in x squared plus 2x minus 23. So that's going to be 1 over x squared plus 2x minus 23 minus 1. Okay, so nothing to distribute outside here, so that's just going to be 1 over x squared plus 2x negative 23 minus 1. And now let's simplify this. That's going to be 1 over x squared plus 2x minus 24. And now let's look for domain restrictions. F of x has no domain restrictions. And now let's look at our newly composed function. It does not matter what p's domain restrictions are. So we're going to have some different domain restrictions here, okay? Notice the denominator can't be 0. So we have to solve for when does x squared plus 2x minus 24 equal 0. That's going to be factorable. That's going to be x plus 6 times x minus 4 equals 0. We'd get x equals negative 6. We'd get x equals 4. So these are the two values that make our denominator 0. So we need to make sure we say that the domain is all real except negative 6 and 4. Okay, so make sure when you do a composite function, okay, you're sticking one function into the other function. And make sure you are stating the domain of the resultant composite function. You check the inner function for domain restrictions, and you check what you got as your new function. Now, before we close out function composition, okay, why don't we do one more thing with these functions, and that is the following. Okay, you're going to evaluate. So number 1 says f of g of 2. So you're actually going to get an output value. Okay, this says we're going to evaluate f of g of x when x is 2. So to do this, the first thing we want to do is we want to know, okay, what this is basically saying is the input of f is whatever g of 2 evaluates to be. So we need to know what g of 2 evaluates to be because that is the input of f. So g of 2 would be 2 times 2 minus 5. That's going to be 4 minus 5. That's going to be negative 1. So we're really evaluating f of negative 1 because that was the output of g of 2. So that's going to be negative 1 squared plus 2 times negative 1 minus 23. So it's going to be 1 minus 2 minus 23. That's going to be negative 24. So what does f of g of 2 evaluate to be? Negative 24. There's no domain you're giving here, okay? You're actually plugging a number in and getting its output, okay? Number 2. Number 2, why don't we say, let's do g of n of 8, okay? G of n of 8. So first thing is, I'm taking g, and I'm going to plug into g whatever n of 8 is. So I need to first figure out what n of 8 is. So that's going to be the square root of 8 plus 1, square root of 9. What's the square root of 9? 3. So now I'm evaluating g of 3, which would be 2 times 3 minus 5. 6 minus 5. This evaluates to be 1. Okay, let's do another. Number 3, let's do g. No, let's do, instead of that, let's do n of g of 1. Okay, so we're going to take n and evaluate it at the output of g of 1. So the first thing we have to get is what is g of 1? That's 2 times 1 minus 5. So that's going to be 2 minus 5, that's going to be negative 3. So we're going to do n of negative 3. And that's going to give us the square root of negative 3 plus 1. So that's going to give us the square root of negative 2. Is that a valid output? No. So should we have ever plugged 1 into n of g of x? No. This does not exist. Okay? You should have never plugged 1 in. if we would have done n of g of x and looked at the domain of that, which we did, right? We got that x had to be greater than or equal to 2 as the domain of that, don't forget. You wouldn't actually be able to plug 1 in, so you just write this happens, and you get something that's not real, you can just say that it does not exist. So let's just do one more. That was number 3. Number 4, let's do. Okay, f of g of n of 0. So we're taking f and we're going to evaluate it at g of n of 0. So we're taking g and evaluating of n of 0. So the first thing we need is n of 0. N of 0 would be the square root of 0 plus 1. So it's going to be the square root of 1. The square root of 1 is 1. So now we're going to take g and plug in 1 because this is now 1. So g of 1, that's going to be 2 times 1 minus 5. So that's going to be 2 minus 5, so that's going to be negative 3. Okay, so now we know that this is negative 3, so we're doing f of negative 3. Okay, and that's going to give us negative 3 squared plus 2 times negative 3 minus 23. It's going to give us 9 minus 6 minus 23. 3 minus 23 gives us negative 20. So the output of f of g of n of 0 would be negative 20.